In 1988, the U.S. Air Force retired the legendary SR71 Blackbird, unmatched in speed for decades. Now its successor, the SR72 Dark Star, has arrived, confirmed real and designed to exceed Mach 6. With cutting-edge stealth and propulsion, it leaves rivals like China and Russia racing to keep up. More than just fast, the SR-72 can strike targets globally within minutes, redefining the future of aerial warfare. The birth of the SR-71. During the Cold War, the United States faced an urgent need for superior aerial reconnaissance. Spy planes like the U-2 had already been employed to monitor Soviet activities, but the vulnerability of these aircraft became painfully clear when one was shot down in 1960. The U.S. realized that altitude alone was no longer enough. They needed speed, altitude, and stealth. Enter Lockheed's Skunk Works division, led by the legendary engineer Clarence Kelly Johnson. The result of their innovation was the SR-71 Blackbird, an aircraft unlike anything seen before. Flying at Mach 3.3 at altitudes over 85,000 feet, the Blackbird was capable of outrunning any missile fired at it. If detected, it didn't engage in combat, it simply flew faster and higher. Revolutionary design and engineering. The SR-71's revolutionary design featured a titanium airframe, sourced covertly from the Soviet Union, that withstood extreme heat, generated at high speeds far beyond what aluminum could handle. Its sharp edges, radar-absorbing coatings, and heat-expanding wings made it nearly undetectable and structurally stable at supersonic speeds. The cockpit used a quartz window framed in titanium, while its nitrogen-filled, aluminum-infused tires cost $2.3 million per set and lasted about 20 flights. The aircraft leaked fuel on the ground, sealing only once airborne, and required a drag parachute for rapid landings. Despite its complexities, no SR-71 was ever shot down, highlighting its unmatched performance. Aerodynamic innovations. One of the most intricate parts of the SR-71 was its air inlet system, featuring a moving spike that managed airflow into the engines. At lower speeds, the spike remained fully extended. As the aircraft accelerated past Mach 1.6, the spike automatically retracted to regulate air compression and maintain engine stability. This technology was controlled by early analog computers, which occasionally caused inlet unstarts, leading to engine shutdowns or sudden lateral movements. Eventually, these analog systems were replaced with digital controls, greatly improving reliability. Additionally, the Chinese, sharp leading edges at the front, were initially designed for stealth, but ended up enhancing flight stability and engine performance, especially at high speeds. NASA's research later confirmed that these design features significantly improved the Blackbird's aerodynamics. Powerhouse engines. The SR-71 was powered by two Pratt & Whitney JA58 engines, each generating 32,500 pounds of thrust. As speed increased, afterburners became the main thrust source, while complex airflow management controlled extreme heat at Mach 3+. Initially, Buick Wildcat V8 powered carts were used to start the engines, later replaced by quieter air systems, though the carts remained in remote use. The jet burned specialized JP7 fuel, ignited by injecting triethylborane, which produced a signature green flash. To minimize stress, the SR-71 launched only partially fueled, refueling mid-air with specially modified KC-135Q tankers. Advanced navigation and reconnaissance. Navigation was handled by a star tracking system that allowed the Blackbird to correct its course with remarkable precision, drifting no more than 1,000 feet even at Mach 3. This celestial navigation was crucial for long missions. The SR-71 carried a variety of reconnaissance equipment, including wide-angle and zoom cameras, radar systems, and electronic signal interceptors. Over time, its onboard technology was upgraded to include more advanced systems for gathering intelligence while remaining undetected. To protect its crew, who faced extreme temperatures and pressures at high altitudes, pilots wore specially designed pressure suits that provided oxygen and thermal protection. Even simple tasks like eating required custom containers with straws that could be used inside their helmets. Political struggles and retirement. Despite its unmatched capabilities, the SR-71 faced political and financial obstacles. High operational costs and the rise of alternative intelligence gathering methods such as satellites and drones contributed to its retirement. Critics often cited its inability to transmit real-time data, unlike platforms like the U-2. In 1989, the SR-71 was retired from active service. While Congress initially funded continued operations, internal resistance within the Air Force and Department of Defense hindered these efforts. Even after several temporary reactivations, including brief operations in the 1990s, the program was ultimately shut down in 1998. NASA continued flying a few remaining aircraft until 1999. Enter the SR-72 Dark Star. Today, with global threats intensifying, especially from nations like China and Russia, the U.S. has turned to the SR-72 Dark Star to continue the Blackbird's legacy. First revealed by Lockheed Martin in 2013, the SR-72 is designed not only for reconnaissance but also for combat, forming part of the Air Force's ambitious next-generation air dominance program. Unlike its predecessor, the SR-72 will be armed with advanced munitions, including high-speed missiles, precision bombs, and potentially laser-directed energy weapons. It will also deploy sophisticated sensors, drones, and long-range imaging systems, offering real-time battlefield intelligence, hypersonic breakthroughs, and unparalleled stealth. One of the most revolutionary aspects of the SR-72 is its tailless, triangular design that eliminates vertical stabilizers, significantly enhancing its stealth capabilities. Inspired by how birds control flight, the SR-72 employs active flow control, a breakthrough that manipulates airflow for precise maneuverability while minimizing radar detection. However, this sophisticated design comes at a steep price. While the B-2 Spirit stealth bomber costs around $2 billion per unit, the SR-72 development alone has already required over $1 billion from NASA. The Air Force has allocated more than $10 billion to next-generation air dominance, while the Navy plans an additional $9 billion in the coming years. A technological marvel. The SR-72 is expected to be equipped with skin-integrated sensors that allow the aircraft to detect threats, targets, and allies while sharing data with other aircraft in real time. It will use powerful new adaptive engine transition program engines, valued at $6 billion, that provide thrust capable of sustaining hypersonic speeds exceeding Mach 6. Advanced electronic warfare systems will jam enemy signals and ensure secure communication links. In addition, the SR-72 is designed with modularity in mind, allowing future upgrades as newer technologies emerge, ensuring that the aircraft remains relevant in rapidly evolving combat environments. The rise of civilian hypersonic aviation. While the SR-72 dominates military headlines, the private sector is also racing toward hypersonic innovation. Atlanta-based company Hermeus is developing the Quarter Horse, a hypersonic aircraft aimed at both military and commercial use. With $60 million in funding from NASA and the U.S. Air Force, the Quarter Horse offers remarkable capabilities. Powered by a modified turbine-based combined cycle engine derived from the General Electric J85, the Quarter Horse can reach Mach 5.5, making it slightly slower than the SR-72 but still incredibly fast. Generating 5,000 pounds of thrust with afterburner assistance, it promises to slash transcontinental travel times, potentially allowing flights from New York to London in just 90 minutes. Hermeus emphasizes simplicity, automation, and reusability to keep development costs surprisingly low, targeting under $100 million, a fraction of traditional hypersonic programs. The future of hypersonic aviation. The dawn of hypersonic flight signals a dramatic shift in military and civilian aviation. With the SR-72 poised to redefine air dominance and companies like Hermeus pioneering commercial hypersonic travel, we are entering an era where speed and technology will fundamentally transform global mobility and warfare. As adversaries race to catch up, the US maintains a critical edge through the innovation of programs like the SR72. Once again, Lockheed Martin's Skunk Works may shape the skies of tomorrow just as they did with the legendary SR71 Blackbird decades ago. And that wraps up our deep dive into the legendary SR71 Blackbird and its mind-blowing successor, the SR72 Dark Star. If you enjoyed this journey through the world of hypersonic aviation and futuristic military tech, make sure to smash that like and hit that subscribe button.